right, question number 19 from section 4.2. Find the present value of $2,000 if the annual interest rate is 6.5% compounded quarterly for 5 years. In this question, we actually are asked to find the present value. So what we are looking for out of all these variables, P, that's going to be our unknown. So we need to know what A is, the accumulated value, R, the rate, N, the number of compounding periods, and T, the time. If we can plug in A, R, N, and T, we can solve this equation for P, the present value. The first number given here is $2,000. That's the amount of money that's you're going to be accumulating at the end of the term. So this is going to be 5,000, I'm sorry, not 5,000, 2,000 is your accumulated value. The rate is 6.5%. Write it as a decimal point, 0.065. Move that decimal place over 2 spaces in the other direction. Sorry, over 2 spaces and fill in that space with a 0. N is the number of compounding periods. If it's compounded quarterly, that means every quarter of a year the interest is compounded. That means 4 times a year the interest will be calculated, compounded. And then the last number we're given is this 5 years. So we're given $2,000 accumulated value, 6.5% is your rate. It's compounded quarterly, that's how we get N equals 4. For 5 years, that means our T is equal to 5. We're going to plug all that into our formula for compounded interest. Accumulated value is $2,000. P is what we're searching for. Find the present value. R is 0.065 divided by 4. All of it raised to the n times t power, 4 times 5. I'm going to simplify this equation by simplifying what's inside the parentheses. I'm going to do 1 plus 0.065 divided by 4. And that gives me P times 1.01625 raised to the 4 times 5 power. That's the 20th power. Okay, see what I did there? Multiply, simplify what's in the parentheses. The whole exponent is 4 times 5, 20. Now I want to get the P by itself. I'm going to divide both sides by 1.01625 to the 20th power. Divide that by both sides, 1.01625 to the 20th power. And those are going to divide out. So I'm going to be left with my P. P is the present value. Use a calculator for this part. We're going to take $2,000 and divide it by 1.01625 raised to the 20th power. That present value is calculated at $1,448.83. So in our present value, that's how much you would begin with. Begin with $1,448.83. Invest that at 6.5% compounded quarterly for 5 years. That $1,448 is going to grow to $2,000. So you'll be earning interest on that. The present value, just check my answer. Okay, so this is a problem where we need to find the present value when we're given the accumulated value. And the last question from section 4.2, we want to do some comparisons here. Bank A is lending money at 5.55% compounded quarterly. The rate at Bank B is 5.6% compounded annually, and C is 5.5% compounded monthly. Which bank will you pay the least interest? If you're going to be borrowing some money and you've got different banks that are offering different rates and different compoundings, you don't necessarily want to go with the lowest printed rate because the compounding affects how much interest you'll end up paying. So which one is better? Which bank is better? Now you're not given a present value. You're not given a time. You are given the rates and the types of compounding. So to do these comparisons, we're going to pick a value for the present value. You're going to let P equal, well, the amount of money that you're going to borrow at each bank should be the same. Now that amount's not given, so let's make it easy on ourselves by making the P $1. Now the reason I chose $1 is because no matter what, if I borrow $1 from Bank A, Bank B, Bank C, at the end I'm going to owe them money with interest. So even if I borrowed $1,000 or $10,000, the amount is going to be the same for each one, and you're going to do some comparisons on the future value. So make it easy on yourself and let P equal 1. Another thing you can do is let the T, the time, you're not given any information here about the time. So you're going to let that be 1 year. So compare at the end of the year, Bank A, B, and C. If you borrow $1 from each one, see how much in which bank you're going to end up owing more interest. So you can make the comparisons that way. We're going to be using this formula for accumulated value. I just moved some things around so that we can have room to do all the comparisons here. I'm going to look at Bank A, Bank B, and Bank C. So in Bank A, the interest for Bank A, the rate is 5.55%. Move that decimal and fill in with a 0. Bank A, the rate is 0.0555. And it's compounded quarterly, so n is going to equal 4. That's our Bank A. Now let's break this down. Bank B. Bank B is 5.6%, so R is equal to 0.056, and it's compounded annually, so n is going to equal 1. Now let's compare that to Bank C, where the rate is 5.5%, 0.055, compounded monthly, so n is going to equal 12. We're going to plug in P and T both equal to 1 for all 3 banks. P equals $1, T equals 1 year, and then we're going to just do the comparison for each of these and see how much you end up owing at the end of the year for each of these accounts. Okay, using the formula, A equals P times 1 plus R over N to the NT, and plugging in what we know, it's going to be $1, 1 plus 0.0555 divided by 4 raised to the 4 times 1 power. Use a calculator. 1 times 1 plus 0.0555 divided by 4, raise it to the 4 times 1 power. I'm going to put that in parentheses, 4 times 1. At the end of the year, that $1, you would end up owing 1.05666, and so on. 658. So $1.05, almost $1.06. Let's do the same thing for bank B. It's going to be A is equal to your dollar you start off with, 1 plus 0.056 over 1 to the 1 times 1. 1 times 1. Use a calculator to evaluate that. So in bank B, that amount is going to be $1.056. So bank A, you're going to owe more. B is so far better. Let's look at bank C. A would equal $1 times 1 plus 0.055 over 12 times 12 times 1. Sorry about that. It's getting kind of tight there. But 12 times um, 12 times 1. So in the calculator, it's 1 times 1 plus 0.055 divided by 12. All of that raised to the 12 times 1 power. And then you get the amount is 1.056407. Now you can make the comparisons here. They all look very close. It's only $1. You can see they're all about $1.56, around almost 6 cents interest that you would have to pay. Doesn't seem like a big difference here, but if you're talking about thousands of dollars over many, many years, that can make a huge difference in the amount of interest that you pay. Think about home mortgages. You're going to be spending a lot of money on interest. So the cheapest bank here is bank B. Even though the rate is the largest, it ends up being the cheapest because of how the interest is compounded.